Okay, welcome back to Calc AB videos, and in this one we're just going to do a pretty holistic review of derivatives, and we'll try to get in maybe a short 5-minute video after this, just doing a handful of practice examples where you can try them on your own first and then check them out. So we're going to cover two derivatives before reviewing or doing a refresher on trigonometric derivatives. We're going to cover two derivatives that are different from any other, or different from at least about 90% of the other derivatives you'll do. So you remember the common power rule that we used in the last video. Well, these two derivatives, the power rule doesn't apply to them. The derivative of e to the x is not going to be x times e to the x minus 1, depending on whatever value x is. So these are some pretty important derivatives to note down, especially because you use them in integrals as well, and they have some unique rules in integration too. You'll see that later on once we cover integrals and integration, but let's get right into this. So the derivative, actually let's make that an arrow. So if you're given a function e to the x, the derivative of e to the x is going to be e to the x. Now you may be asking, well, if derivative of e to the x is just e to the x, then is there going to be any variation in these derivatives? Yes. So if you recall the chain rule from some of the previous videos, we might have to apply something similar in cases like this. So let's say you have, let me make that equals. Let's say you have f of x is equal to e to the 2x. Now the derivative of e to the 2x is not going to be e to the 2x. The derivative of this is going to be 2e to the 2x. So overall, the general form of an e to the x derivative, we'll call this function, e to the u, is going to be equal to u times e to the u prime times e to the u. So taking e to the x into account using this pattern, we know that the derivative of x is just 1. Right, so we multiply e to the x by 1, which is just e to the x, and the e to the x part remains the same, which is why the derivative of e to the x is e to the x. And that's why the derivative of e to the 2x is going to be 2e to the 2x. You're multiplying your original function by the derivative of that power. Now moving on to ln functions, ln of x is going to be, if you're given the derivative, is going to be 1 over x. Now, once again, there are going to be some weird chain rule, pattern rule kind of things over here, so I'll go ahead and just flesh them out. So maybe you will have ln of 2x. So the derivative of this is not going to be 1 to the 2x, but instead it's going to be 2 over 2x, which actually ends up being 1 over x, if I'm correct. So the general form for this, let's say you're given an ln of u function. The derivative of ln of u is going to be u prime over u. So taking 2x, let's confirm this example. So 2x, well, u prime, right? You have to take the derivative of your inside function, which is 2x, which is just 2. So you get u prime over u, and our u function, our original function, was 2x. So yes, the derivative of ln 2x is going to be 2 over 2x, which simplifies to 1 over x. Now keep in mind all other rules will apply the same thing over here. So if you have a constant multiplied by an e to the x function or an ln of x function, you can take the constant back, or you can take the constant out and take the derivative of your ln x or e to the x function and multiply by the constant at the end. Great, so now that we've got that out of the way, let's do some quick trigonometric derivatives refresher. So there isn't much deducing to this. Each derivative will really be somewhat unique, and there's obviously going to be those applications of the chain rule which you'll very much have to keep in mind. So let's just kind of write down the most basic derivatives. So I'll just write them down. So sine of x, let me make that a little less thicker so we can fit some more space. Okay, so sine of x is going to get you cosine of x. Now keep in mind, we're going to be putting in parentheses around these x because we're going to treat these as our inner functions. Whenever you use a chain rule aspect or some type of pattern with trig derivatives, you'll have to take the derivative or the integral of the inside function, and that inside function is x. So for all intensive purposes at this moment, we're going to have our function just being x, and the derivative of x is going to be 1, which is why the chain rule isn't going to show anything special here. But you might end up with functions like sine of 2x or 3x, in which case the derivative is not 1, so you actually have to multiply or add in numbers. So cosine of x gets us negative sine of x. These are the two most common ones that you'll be using, and some other ones just for basic functions. So tangent of x is going to get us secant squared of x, or secant of x squared. We'll go secant of x gets us secant x tangent x, and then we're going to have our, just like we had cosine and secant, we'll have cosecant and cotangent. So the derivative of cosecant x is going to be negative cosecant x cotangent x. So you'll see some slight patterns within these derivatives, and the derivative of cotangent x is going to be negative cosecant squared of x. So most of these do match up or display a pattern of some sort, so just keep these in mind. I'll try to maybe do some kind of derivative review, especially for trig derivatives, every couple or so videos, and it'll get to the point where whenever we're doing practice problems in these sorts of videos, you'll just kind of end up using them naturally. So now that we have established basically all the base level derivatives that we'll be using this year and probably next year for Calc BC, let's go ahead and do some practice problems to show you how they work. And we're not going to take some base practice problems using just x. We're going to try to use the chain and power rule in these problems, and obviously the multiplication and division rules that we previously established for derivatives. So let's start off our first problem. Our function is going to be x squared times ln of 5x. What is the derivative of this function? Okay, so I'll assume that you've taken a couple seconds to just pause the video and try it on your own at this point. You can go back in, you can just rewind the video a little bit and just look at these, but I'll leave them on screen. So at this point, you can pause the video and use some of the notes I have above to try this on your own. And I'll assume you've done so. So I'll go ahead and solve this out. So we're going to use the product rule. These are two functions that are being multiplied. We'll call this function 1 and function 2. So we want to take this function, so we're going to do 1 times the derivative of 2 plus the derivative of 1 times 2. And what does that get us? Well, that gets us x squared times, well, what is the derivative of ln 5x? Treating 5x as our u function, it's going to be u prime, which is 5, over u, which is 5x, and this cancels out to 1 over x. So let's write that, and then plus the derivative of our first function, which is x squared, which just gets us 2x times ln x. Now putting all of this together, well, x squared times 1 over x just gets you x, so this is just x, and that cancels out, plus 2x ln x. So our final answer is going to be x plus 2x ln of x. So you'll see how these rules are all applied. Now let's do a practice with some e to the x functions. Let's try taking let's say our original function is going to be x squared plus 5 e to the 2x. What is the derivative of this function? Now these two functions are not being multiplied, so we can derive them separately and add their derivatives at the end, treating this as two separate functions, a and b. So we'll take the derivative or a function first, and we know that the derivative of x squared using the power rule is just going to be 2 times x to the 1, which is just 2x, plus, okay, now 5 is a constant, so let's just write that here, because we know that constant is going to factor into our derivative no matter what. And now let's take the derivative. Well, the derivative of e to the u is u prime times e to the u. Treating 2x as u prime is 2, so we get 2e to the 2x. And then simplifying this, we get our final answer to be 2x plus 10e to the 2x. Okay, let's try doing one last quick example with some trigonometric derivatives. So let's do some slightly complex one. So let's say we have x squared times sine of x squared plus ln of 4 ln of 3x. Let's try this. This looks very complicated. So how do we approach this sort of problem? Well, notice that we're going to have to use the product rule for these two, but we can use the addition rule for the overall thing. So treating this function as a, and this entire function is b, we can split this into our first b function and our second b function. So we'll apply the product rule to b1 and b2 over here. So first we want to multiply our first function by the derivative of the second function. So x squared times the derivative of sine of x squared. Actually, you know what, let's make, instead of sine of x squared, let's go sine of 10x. Okay, so x squared times, well, what is the sine of 10x? Looking at our derivatives here, we get sine x, it becomes cosine x, but we have to multiply that by the derivative of our inside function, which is 10. So we get 10 cosine of 10x. Then plus the derivative of our first function, which is 2x times sine of 10x. So that's the derivative of our b function, and now we can add that on to the derivative of our a function. Plus, what is the derivative of our a function? Well, 4 is a constant, and ln of 3x gets you u prime, treating this 3x as our u, so u prime over u. And this factors out to 1 over x, and so we can say that this becomes 4 over x. So what do we get with our final answer? Let's combine this, and we're going to get x squared 10 cosine of 10x plus 2x sine of 10x, once again, plus 4 over x. And that becomes our final answer. So this must have been a pretty complicated problem for a lot of you guys, which is why I spent some time walking you through it. Now in the next maybe 1 or 2 videos, we'll try to just do a bunch of practice problems with variations, just to kind of get you guys used to the process.